Alright, so brief review over conic sections. So we're going to have the parabola, and then we're going to have the ellipse, and included in the ellipse is the circle. So a circle is a type of an ellipse, so it's going to fit into that category. And then we have the hyperbola. So these are our three conic sections. So what we want to remember first about conic sections is that they are all derived from cutting a cone. Conic section, slice or cut a cone. So our parabola comes when we do a slice that is parallel to the side of the cone. Parallel, parabola, goes together. Our ellipse comes from doing this type of cut across the cone. And then the circle is when that cut is parallel to the base, then you get a circle. Now, when we take a double napped cone and we cut it like this, then we get the hyperbola. So the hyperbola is where we have the two disjoint curves. So that's an overview of how those cuts create the curves. So with our parabola, that's the one we're most familiar with from Algebra 2. Our parabola can either open up or down or left or right. And the way in which the parabola opens dictates the equation, or rather, I guess the equation dictates the way that the parabola opens. So what you want to think about is if it's opening up and down, it's like a y equals x squared. So it's going to be like this. X minus h squared equals 4p times y minus k. And if it opens to the side, the y is going to be squared. So it's going to be y minus k squared equals 4p times x minus h. hk is our vertex. But we get this letter p. And so p, sometimes people forget what the p represents. So p is the distance from the vertex to the focus. So for example, right here is my vertex. My focus is inside my parabola. The distance from the vertex to the focus, that's P right there. That is also equal to the distance from the vertex to the directrix. So remember, the directrix is actually the perimeter of your circular base on your cone. And so think about when we did our patty paper and we folded and we made a line, and that line was the directrix, right? And then we made the directrix touch the focus, and so we were folding that distance in half. And so the distance from the vertex to the focus is the same measurement as the distance from the vertex to the directrix, and they are both represented with the letter P. All right, on our ellipse, main point is that we have two axes. We have a major and a minor axis. The major is always the longest. And the longest major axis is always going to be associated with the letter A. The length of the major axis is 2A. Length of the minor axis is 2B. And so that A being longest, that's going to tell you which way your ellipse is oriented. So, if you have x minus h squared over a squared plus y minus k squared over b squared equals 1, what this tells you, when your x is with your a squared, that tells you that your major axis is going to go horizontally. And if you have x minus h squared over b squared plus y minus k squared over a squared equals 1, so when your y is with your a, that tells you that your major axis is going to go vertically. Alright, so then we studied the hyperbola, and the hyperbola also has two axes, but they're not called major and minor anymore. Now, they're called transverse and conjugate. And the transverse is the one that has the vertices on it. So transverse literally means to move between vertices. So if we have x minus h squared over a squared minus, hyperbolas have the minus in between, y minus k squared over b squared equals 1. So if our x is coming first, then our transverse axis is going to be horizontal. But if we start with a y minus k squared over a squared minus x minus h squared over b squared equals 1. So if we lead with the y, then our transverse axis will be vertical. Alright, so get a partner to talk with, not your whole team, just talk with one other person. And depending on where everybody's sitting, it could even be somebody who's not in your team. Everybody get a partner and share two things from this information. Because when we talk, we learn.
Alright. So in an ellipse, or in an ellipse, the major axis is the longest axis. In the parabolic equation, it represents the distance from the vertex to the base.
The two axes are the transverse and the conjugate. The transverse is where you find the vertices, so it's vertices to the halfway point basically. And the conjugate is where it the distance between it and the
I think it's between the co-vertices.
Asymptote.
Yeah, that's why you get that off shape, because you're going up to the vertice, and then you get that A, and then you get B, which is where it reaches the asymptote, and then you get so triangle, 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 triangle.
Alright, let's come back together.